Dear students, welcome to our YouTube channel ChemOrigin. This is Dr.Satish Kumar.
Dear students, in the last video module, that is module 10, video module 10, we discuss about in an organic reaction, out of the reactants, which one acts as a substrate, which one acts as a reagent. We already discussed it detailedly. So once I will repeat, students, in an organic reaction, organic molecules participate in a reaction and gives the corresponding products through formation of a unstable intermediates. So students, in an organic reaction, a molecule which supplies carbon to the new bond formation is taken as a substrate and the other reactant is considered as a reagent. So students, we know very well in a given organic reaction which one acts as a substrate and which one acts as a reagent. So in an organic reaction, a molecule which supplies carbon to the new bond is known as a substrate and the other reactant is taken as a reagent. For example, students, you can take one example here. Ethene or ethylene. Students, we know very well the name of this compound, CH2 double bond CH2 double bond CH2. Ethylene or ethene. Whenever ethene or ethylene is treated with bromine Br2, it forms a product, stable product, 1,2-dibromoethane, 1,2 dibromoethane, 1,2 dibromoethane, 1,2-dibromoethane as a product. Students, in this example, initially ethylene supplies a carbon to the new bond formation. Hence, ethylene or ethene is considered as a substrate. Here, bromine is added to the ethylene. Therefore, bromine is a reagent. Students, in some organic reactions, both the reactants supplies carbon to the new bond formation. In that cases, out of the two reactants, the organic molecule on which more intention is focused during the reaction is taken as a substrate and the other reactant is taken as a reagent. For example, students, here you can see whenever benzene, this is benzene, we know very well students, this is the benzene structure. Students, we know very well benzene, its molecular formula is C6H6 benzene, and whenever benzene is treated with chloromethane or methyl chloride CH3Cl, it is known as a chloromethane, or you can call as a methyl chloride. Both are correct, methyl chloride or chloromethane. Whenever benzene is treated with methyl chloride, it gives a corresponding product is toluene, benzene having methyl group. Students, we know very well the name of this compound is toluene, TOLUENE. Benzene having methyl group is called toluene. Toluene is the common name and its IUPAC name is methyl benzene. Methyl benzene is the IUPAC name of the product, methyl benzene, or its common name is toluene, methyl benzene or toluene as formed as a product. So students, in this reaction both methyl chloride and benzene both are providing carbon to the new bond formation. But however, here what happened, benzene is the more focused one in this reaction because on the benzene ring the methyl group is substituted. Therefore, this benzene ring is considered as a substrate. This benzene ring is taken as a substrate and methyl chloride or chloromethane reactant is taken as a reagent. So students, whenever benzene is treated with chloromethane, it forms a toluene as a product. Here benzene is taken as a substrate and chloromethane is taken as a product. Therefore, in an organic reaction, if both the reactant supplies carbon to the new bond formation. Therefore, the molecule on which more intention focused is taken as a substrate and the other reactant is considered as a reagent. Dear students, the next important terminology in organic chemistry is nucleophile and electrophiles. Nucleophiles and electrophiles. What are nucleophiles? What are electrophiles? What is what is called as a nucleophile? What is nucleophile? What is electrophile? We see in this slide. Students, in an organic reaction, generally, reagent attack at the reactive site of the substrate molecule. Reactive site of the substrate molecule is attacked by the reagent. Generally, students, for example, in a organic reaction, the substrate is having electron deficient nature. The substrate is having electron deficient nature. Electron deficient nature means it is having lesser number of electrons than octet configuration. It has less than octet configuration, or the some portion of the substrate molecule having positive charge. Some portion of the substrate molecule having positive charge. So that is called reactive site. Reactive site. For example, students, in an organic reaction, for example, if you consider A and B, you can take A and B is your starting materials or reactants. In the out of A and B, A is taken as a substrate and B is assumed as a reagent. Suppose students, the substrate A is having electron deficient nature. So it is having less than octet configuration, or the substrate A having positively charged nature. As a result, that positively charged portion of the molecule or electron deficient portion of the molecule is taken as a reactive site. Reactive site or reactive site. That reactive site is attacked by the corresponding reagent. That reactive site generally attacked by the reagent to form the corresponding product. So students, if your substrate molecule having electron deficient nature, then the reagent is having a electron excessive nature, because substrate is electron deficient nature. Therefore, reagent will act as a electron excessive species, means it may have a lone pair of electrons, or it may have a negatively charged, because the substrate portion, some portion of the substrate molecule having positively charged. In that case, reagent will donates a pair of electrons, because substrate is electron deficient nature. Therefore, the attacking reagent having a pair of electrons or having a negative charge is attacked at the reactive site. The portion, electron deficient portion of the substrate or positively charged portion of the substrate is taken as a reactive site. Therefore, the reagent which is having a pair of lone pair of electrons, or it is having a negatively charged reagent, will attack at the reactive site of the substrate, gives the corresponding product. Let us assume the product is AB. Let us assume the product is AB. Students, in this, the reagent, here we are assumed B as a reagent. Here reagent donates a pair of electrons to the substrate, or reagent having negative charge. So students, the reagent which donates a pair of electrons to the substrate in an organic reaction is known as a nucleophile. Nucleophile. Students, this nucleophile name, if you divide the name of this nucleophile into nucleo plus phile, nucleo plus phile. Students, nucleo means generally nucleons. Students, we know in an atom nucleus is always having positive charge. Students, we know nucleus having positive charge. Phile means attraction. Students, phile means attraction. Phile means attraction, or phile means loving, attractive nature, loving nature. Nucleophile. Nucleophile means positive charged attraction part. Positive charged portion attraction. Positively charged species is attracted. Therefore, nucleophile. Nucleophile means which attracts nucleons or which attracts positive charge. Here phile means loving or attraction. Phile means attraction. Positive charge attraction or positive charge loving. Phile means attraction or loving. Therefore, students, nucleophile means positive charge attraction or which attracts nucleons, because nucleus is having positive charge. Therefore, positive charge is attracted by negative charge. Hence, nucleus is having a pair of electrons. A pair of electrons, or nucleophile may have a negative charge. Students, in short, nucleophile is denoted as a capital N, small u. Generally, students, nucleophile, a general formula for nucleophile is capital N, small u. The general representation of nucleophile is capital N, small u. Nucleophile may have a lone pair of electrons, or a nucleophile having a negative charge. Nucleophile may have a negative charge or a nucleophile having a pair of electrons which attracts the positive charge portion of the substrate molecule or electron deficient portion of the substrate molecule. So students, in organic chemistry, generally the species which is having negative charge, or the species which is having lone pair of electrons, which are acts as a nucleophiles. For example, students, if you see OH minus, hydroxide ion, OH minus, so here negative charge is present. This negatively charged OH acts as a nucleophile. Because it is having negative charge, it readily attracts the positive charge. Similarly, another example for nucleophile is Cn minus, cyanide anion, cyanide anion, Cn minus. So it is also having a negative charge. It readily attracts by the positively charged species. Therefore, in generally, nucleophiles are the species which is having a negative charge. And also students, there are some nucleophiles which does not have a negative charge, even though it has a lone pair of electrons on the atom. For example, students, if you take H2O, water molecule, water acts as a nucleophile, because in water molecule the oxygen is having two lone pair of electrons. Oxygen is having two lone pair of electrons. So it has a ability to donate a lone pair of electron to the electron deficient portion of the substrate molecule. Similarly, student, you can take another example, trialkyl amine. Trialkyl amine. Here R3, R means alkyl group. That may be methyl, that may be ethyl, that may be propyl, aryl, allyl, vinyl, alkynyl, whatever it may be, the R group may be taken as a alkyl group. R group may be an alkyl group. So students, R3N, a trialkyl amine. In case of trialkyl amine, nitrogen has a lone pair of electrons. Because of these lone pair of electrons, this trialkyl amine can act as a nucleophile, because trialkyl amine can readily donate its lone pair of electrons to the electron deficient portion of the substrate molecule. Therefore, these are the examples of nucleophiles. So students, nucleophile means which attracts nucleons, which attracts positive charge, which loves nucleons, which loves positive charge, which attracts nucleons, which attracts positive charge. So students, a species which is having negative charge, or a species which is having lone pair of electrons, may act as a nucleophile. Electrophile. Students, nucleophile, a species which is having negative charge, or it is having a lone pair of electrons. Electrophile is exactly opposite to the nucleophilic nature. If you divide the name of the electrophile, suppose it can be written as a electron plus phile means electron attraction. Electron attraction. Students, we know electron is having negative charge. Electron is having negative charge. So negative charge attraction. Phile means attraction, loving nature. So negative charge attraction. Electrophile which attracts electrons, which attracts negative charge. Students, suppose in an organic reaction, your substrate molecule may act as a electron excessive species. Electron excessive species. Therefore, it can donate an excess of electrons to the outside species. In that case, the reagent, the reactive, the reactive site attacked by a reagent is having positive nature or electron deficient nature. Electron deficient means less than octet electrons in its valence shell. So electron deficient species, electron deficient species or positively charged species reagent will act as a electrophile because of its positive charge or electron deficient nature. It readily attacks at the reactive site of the electron excessive species, electron excessive portion of the substrate molecule, negatively charged portion of the substrate molecule attacked by the reagent electrophile, reagent electron deficient part, reagent having positive charge. So students, electrophiles means which attracts electrons. Nucleophile means which attracts positive charge. Electrophile which attracts negative charge. Electrophile, electron loving nature. Electron loving nature. Nucleophile, nucleus loving nature. Positive charge loving nature. Students, electrophiles are having electron deficient nature because of it is having a positive charge. Students, generally a species which is having positive charge or electron deficient nature are taken as a electrophiles, are taken as a electrophiles. For example, students, if you take methyl carbocation, methyl cation or methyl carbocation can act as a electrophile. Similarly, students, if you take carbonyl functional group, carbonyl functional group is also acts as a electrophile. Similarly, tertiary alkyl halide or trialkyl halide, trialkyl halide will also act as a electron deficient nature. Because students, here what happen in case of carbonyl species, when you compare the electronegativity of carbon with oxygen, oxygen is having higher electronegativity. As a result, oxygen attracts a electron density towards the oxygen atom. As a result, this carbon will get a partial positive charge, means it temporarily acts as a electron deficient nature to this carbon. Similarly, if you take trialkyl halide, trialkyl halide case also, this halogen is having more electronegative nature. As a result, it is having partial negative charge and the carbon may gets partial positive charge, means electron deficient nature. Because of its electron deficient nature, it attacks at the reactive site, that is electron excessive portion of the substrate molecule. Negatively charged portion of the substrate molecule will attacked by the electrophile. So students, these two are very important terminology in organic chemistry. Nucleophile, electrophile. Nucleophile which donates a pair of electrons to the electron deficient portion of the substrate. Electrophile which takes a pair of electrons from the electron excessive portion of the substrate molecule. Generally, a species having negative charge or a species having lone pair of electron will act as a nucleophile, or a species which is having positive charge or electron deficient nature or acts as a electrophiles. Students, in generally, the electron movement in organic reaction, the electron movement in organic reaction generally represented or denoted with a curly arrow. Denoted with a curly arrow. Students, the electron movement in organic reaction generally denoted with a curly arrow or curved arrow. Curly arrow or curved arrow notation. Curved arrow notation is used to represent the electron movement in organic reactions. So this curved arrow shows the direction in which the electron pair is transferred from one bond to another bond. For example, students, if you see a pi bond, from a pi bond, a pair of electrons moved from a pi bond to a adjacent bond position. Here it is shown with a curved arrow or curly arrow. So generally students, in organic reactions, the electron movement generally takes place in three different cases. The first type of case is the electron pair which is moved from a pi bond to adjacent bond position. Pi bond to adjacent bond position. It is denoted with a curly arrow. From pi bond to adjacent position. After transfer of this pi bond from to the adjacent bond, the species becomes like this. Suppose students, the second possibility is that a pi bond which is transferred to the adjacent atom. A pi bond may transfer to the adjacent atom. It is also denoted with a curved arrow or curly arrow. So after movement of electron from a pi bond to the adjacent atom, now the species becomes like this. The atom has a pair of electrons. The atom has a pair of electrons means the pi bond is shifted to the adjacent atom. Here adjacent means the neighbor atom. Next, another possibility for electron movement in organic reaction is from atom to pi bond. A pair of electrons moved from an atom to the adjacent bond position. A pair of electrons moved from the atom to the adjacent bond position. So students, in organic reactions generally these three types of electron movement takes place. First one is a pair of electrons which are moved from a pi bond to the adjacent bond position, or a pi bond to the adjacent atom. A pair of electrons from an atom to the adjacent bond position. Generally these are denoted with a curved arrow or curly arrow. Students, for example, in order to understand this, for example, if you take hydroxide ion OH minus, hydroxide ion is treated with a methyl bromide. Here a small correction students, this is methyl bromide or bromomethane. Methyl bromide or bromomethane is treated with a hydroxide ion. This hydroxide ion having a pair of electron, this negative charge is moved towards the methyl carbon. After attaching this OH minus to the carbon, this bromine atom will go away with a bond pair of electrons. As a result, we are getting CH3OH as a product and Br minus ions are formed in the reaction. So students, here we are denoted with a curly arrow. The movement of electrons, the electron movement in organic reactions. Here from OH minus to methyl group, from methyl and bromine, the bond pair of electrons are shifted towards bromine atom. So the electron movement in organic reactions generally represented with a curved notations or curly arrow notations. Students, if the reactive species or the intermediates are, radicals, for example students, already we saw in heterolysis we already saw, students, we know in case of heterolysis the intermediates are radicals. the radical intermediates, homolysis, which is denoted with, this is homolysis, In case of homolysis, we know students, in the last video module we discussed, in case of homolysis, radicals are intermediates and which are denoted with a fish hook arrow or curved arrow or curly arrow. Fish hook arrow or curved arrow. Fish hook arrow because it looks like a fish hook. It's look like a fish hook. That's why it is called as a fish hook arrow or half-headed arrow. Half-headed arrow. Fish hook arrow or half-headed arrow. Only it has half head only, or it looks like a fish hook. In case of homolysis, radicals are formed as a intermediate. These radicals formation is denoted with, or homolysis is denoted with, half-headed arrow or fish hook arrow. So students, the electron movement in organic reactions are generally represented in this manner. Dear students, up to now we discuss about the different basic concepts in organic chemistry. In order to understand very clearly, we should do some easy problems in order to understood the basics of the organic chemistry. First problem is, with the help of curved arrow notation, depict the reactive intermediates in heterolysis. So students, here the examiner giving some molecules. So in case of heterolysis, what are the reactive intermediates? Identify the reactive intermediates with the help of curved arrow notation. So one by one we can solve. The first one is CH3SCH3. CH3SCH3. So students, CH3 SCH3. Here heterolysis takes place. So students, we know heterolysis. Heterolysis is denoted with a curved arrow, and it is a completed arrow. So students, if you compare carbon and sulfur, so somewhat the electronegativity of sulfur is more than carbon. As a result, the heterolysis is takes place in such a way that the bond pair of electrons is go away or going towards the sulfur. Means these are the intermediates we are getting during heterolysis of CH3SCH3. So CH3, here carbon lost its bond pair of electron. As a result, carbon gets positive charge. Sulfur takes a bond pair of electrons. As a result, SCH3, sulfur has a negative charge. SCH3 minus. SCH3 minus. So students, CH3 SCH3 on heterolysis, CH3 plus methyl cation, methyl carbocation and SCH3 minus anions are intermediates. Next, CH3CN. Second one is CH3CN. CH3CN. Students, CH3CN, its name is acetonitrile. CH3CN, acetonitrile, CH3CN. Students, generally it is used as a solvent in organic reactions. Its common name is acetonitrile. It is highly popular as a acetonitrile. Acetonitrile. It is generally used as a solvent in organic reaction. Students, if acetonitrile molecule undergo heterolysis, the reaction intermediates are, here students, this carbon is connected with a nitrogen and it is having a lone pair of electron. In addition to that, students, in case of cyano group, there is a triple bond between carbon and nitrogen. In case of cyano group, there is a triple bond between carbon and nitrogen. Students, here the hybridization of this carbon is sp hybridization, and this carbon is in sp3 hybridization. Students, we know very well sp hybridized carbon is more electronegative than sp3 hybridized carbon. As a result, the heterolysis takes place in such a way that the bond pair of electrons will go away or will move towards the cyano group. Therefore, the reaction intermediates during the heterolysis of acetonitrile is CH3 plus CH3 plus means methyl carbocation and Cn minus cyanide anion, cyanide anion, Cn minus cyanide anion. So methyl carbocation and Cn minus anion are the reaction intermediates during the heterolysis of acetonitrile. Acetonitrile. Similarly, students, next example CH3Cu. If you take for example CH3Cu, here the methyl group is connected to the copper. So, student, in case of CH3Cu, here somewhat the electronegativity of carbon is more favor in such a way that than copper. Therefore, the bond pair of electrons will move towards carbon. Therefore, here the heterolysis takes place in this way to form a methyl carbanion CH3 minus, methyl carbanion CH3 minus and Cu plus, copper plus 1 ion, copper 1 plus ion, copper plus 1 ion and CH3 minus anion, methyl carbanion is formed as a reaction intermediates. So students, generally the heterolysis in a molecules is doing in this manner. Next problem, identify the electrophiles and nucleophile in the below given ions or molecule. So students, here the examiner provides some ions and molecules. Identify which are electrophiles and which are nucleophile. This is very easiest question, students. Just now in the previous slides we discussed what is electrophile, what is nucleophile. Students, we know very well the definition of nucleophile and electrophile. So first we can identify electrophiles. Electrophiles in the given molecules or ions. Electrophiles. Electrophiles. So students, we know electrophiles means electrons attraction, which attracts electrons, which attracts readily the negative charge. Therefore, electrophiles attracts negative charge means electrophiles is having electron deficient nature or electrophiles is having positive charge. Therefore, in the given list of compounds or given list of molecules or ions, identify the electron deficient compounds, molecules or ions or the negatively charged species. In the given molecules or ions, BF3 is a electron deficient. Students, we know very well BF3 boron trifluoride. BF3 boron trifluoride is an electron deficient compound because the central boron atom have less than octet configuration of electrons. It has only 6 electrons around the boron atom. Next, Cl plus. So here chlorine species is having positive charge. This is an electron deficient species. Similarly, CH3 C double bond O plus. So this is the electrophilic part. It is acts as a electrophile. CH3 C double bond O. Here the carbonyl carbon having positive charge. Therefore, it is acts as a electrophile. Similarly, students, if you see NO2 plus, nitronium ion, NO2 plus, it is having positive charge, hence it acts as a electron deficient species. Therefore, it behaves as a electrophile. BF3 Cl plus, CH3 CO plus, NO2 plus. In the given list of molecules or ions, these are acts as a electrophiles. Next, nucleophiles. In the given list of ions or molecules, we can identify nucleophiles. Students, we know nucleophile means which attracts nucleons or which attracts positive charge. Therefore, nucleophile should have a negative charge, or a nucleophile will have a lone pair of electrons. So students, in the given list of ions or molecules, the negatively charged species HS minus or SH minus, thiol, OET minus, NH2 minus. So these three are the negatively charged species. These three are the negatively charged species. What are those? SH minus, SH minus. Next, C2H5O minus. Students, this C2H5O minus we can write as a ETO, capital E, small t, capital O minus, OET minus, or C2H5O minus. Similarly, NH2 minus, amide anion, NH2 minus, amide anion, NH2 minus. So students, we know a species having negative charge will act as a nucleophiles. In addition to negative charge, students, some molecules having lone pair of electrons. Lone pair of electrons means electron excessive nature will act as a nucleophiles. So students, in the given list of compounds, trimethylamine, trimethylamine, CH3 thrice N, having a lone pair of electrons on nitrogen, and because of this nitrogen is connected to three methyl groups. Students, these three methyl groups CH3 in trimethylamine, nitrogen is connected with three methyl groups. Students, these three methyl groups will act as a will act as a electron donating groups. These three methyl groups are having electron donating nature, acts as a electron donative groups. As a result, nitrogen is already having a lone pair of electrons. Because of electron donating nature of these three methyl groups, nitrogen can easily donate its pair of electrons to the reactive site or electron deficient portion of the substrate molecule. So students, these are the electrophiles and nucleophiles list of the given ions and molecules. Next problem, find out the electrophilic center in the given molecules. So students, here the examiner ask a question is that examiner giving some molecules, identify the electrophilic center means electron deficient portion of the molecule. Electrophilic means which attracts negative charge, which attracts electrons. Therefore the molecule has a electron deficient portion. So the examiner given some molecules and he was asking, identify the electron deficient portion or nothing but electrophilic center in the molecules. So students, first molecule CH3CHO, CH3CHO, acetaldehyde, acetaldehyde. Students, we know the name of this molecule is CH3CHO. The common name is acetaldehyde, acetaldehyde, CH3CHO. I hope you know very well CH3CHO, acetaldehyde, or its IUPAC name is ethanol. Ethanol is the IUPAC name. Ethanol, 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 ethylaldehyde, or acetaldehyde, acetaldehyde. So students, in the acetaldehyde molecule, we know oxygen is having highly electronegative nature. Students, in the periodic table, fluorine is the highest electronegative element. The second highest electronegative element is oxygen. As a result, oxygen has a ability to attract the bond pair of electrons towards itself. As a result, this carbon is having partial positive charge. So this we can denote it as a, there is a partial positive charge on carbon. It is denoted with a small delta plus, and oxygen is having partial negative charge delta minus. Students, we know very well this symbol means delta, delta, delta plus partial positive charge, delta minus partial negative charge. This is small delta. If it is in triangle form, it is also delta, but it is a capital delta. Small delta, capital delta. Small delta plus small delta minus. It indicates partial positive charge and partial negative charge. So students, in the given molecule, in the given acetaldehyde molecule, this carbonyl carbon CH3CHO, this carbonyl carbon acts as a electrophilic center. It is a electrophilic center because it is having partial positive charge. So this is the reactive center or electrophilic center. This is the electrophilic center in case of acetaldehyde. Next one, next example is methyl iodide. Methyl iodide, CH3I. Students, we know very well the name of this compound, CH3I, methyl iodide. Students, this iodine is a halogen. So when we compare the electronegativity of carbon and iodine, somewhat iodine is having little higher electronegativity. So generally the bond polarity is exist in such a way that the bond pair of electrons, the bond pair of electrons will go towards iodine, and here the electrophilic center or the partial positive charge part, this center is this carbon, methyl carbon. Therefore students, this is the electrophilic center in case of methyl iodide. CH3 carbon, this carbon is the electrophilic center in case of methyl iodide. Next one, CH3CN. This is students, its common name is acetonitrile. This is used as a, this is popularly used as a solvent in many organic reactions. CH3 C triple bond N. CH3 C triple bond N. Its common name is acetonitrile. Acetonitrile. CH3 C triple bond N. It is popularly used as a solvent in many organic reactions. Students, we know a triple bonded carbon, the hybridization of this triple bonded carbon is sp hybridized carbon, sp hybridization, sp hybridized carbon, and this methyl carbon is sp3 hybridization. So students, we know the electronegativity, we know electronegativity of sp carbon is more than the electronegativity of sp3 carbon. sp3 carbon, when we compare the electronegativity of sp hybridized carbon and sp3 hybridized carbon, sp hybridized carbon is highly electronegative. As a result, this methyl carbon will has a partial positive charge, and this cyano group carbon, this cyanide carbon has a negative charge. Therefore students, in case of acetonitrile CH3CN, CH3, this carbon is the electrophilic center, means electron deficient portion of the acetonitrile molecule. So students, in case of acetaldehyde, this carbonyl carbon, this carbonyl carbon is the electron deficient portion or electrophilic center. In case of methyl iodide, this methyl carbon is the electron deficient portion or electrophilic center. Next, in case of acetonitrile, this CH3 carbon, this carbon is the electrophilic center or electron deficient species. So students, in a given organic reaction, we can easily identify which portion of the molecule will has a electron deficient nature, or the given molecule has an electron excessive nature, and which one in the given reactants, generally which one acts as a substrate and which one acts as a reagent, whether the reagent is having nucleophilic nature or electrophilic nature. If a species having negative charge or a species having excess of electrons, which acts as a nucleophiles, or a species having positive charge, or if a species is having electron deficient nature, acts as a electrophile. So in this manner we can identify whether the given molecules are which portion of the molecule having electrophilic nature or electrophilic center, or which part of molecule having nucleophilic center. Okay, students, I hope you enjoyed this session. Students, in this video module, we discuss about the what is electrophile, what is nucleophile, means the definition of electrophile and nucleophile, and how to identify the electrophile and nucleophile. Along with, we also discuss about the electron movement in organic reactions. Generally, the electron movement in organic reaction generally denoted with a curved arrow or curly arrow in case of heterolysis. Whereas in case of homolysis, the electron movement denoted with a fish hook arrow or half-headed curly arrow. Students, in the electron displacement, in the electron movement may takes place from pi bond to adjacent bond, or the electron displacement from pi bond to adjacent atom, or the electron displacement from an atom to adjacent bond we can observe. And also we do some little problems to identification of electrophiles and nucleophiles, identification of electrophilic centers. So some little problems we work out on that. Okay, students, thank you very much.